Alright, so in this video we are going to be talking about radicals. And the first step is we need to go over some rules that pertain to radicals. And if you don't know, a radical is just a square root. So, for example, the nth root of a times b. The radical would be the square root. Inside could be anything, the n value could be anything, and that's considered a radical. So if we had the nth root of a times b, that can be rewritten as the nth root of a times the nth root of b. And so an example to show that is if we had the square root of 9 times 16, that can be rewritten as the square root of 9 times the square root of 16. So that would be 3 times 4, which would be equal to 12. Now if we had the nth root of a over b, similarly, that can be rewritten as the nth root of a over the nth root of b. And so an example to show that is if we had the cube root of 64 over 8, that could be the cube root of 64 over the cube root of 8, which, if we simplified, would be 4 over 2 or 2. So our last rule we're going to use is if we had a to the power of m over n, that would be equal to the nth root of a to the power of m. Some people like remembering this as flower over root, right? Your flower is above your root. So when you have a fraction in your exponent, your flower, the numerator, the m value, would be your exponent, and your denominator, the root, would be the root. So this can also be written as the nth root of a to the power of m. So we can pull that exponent out and move it to the outside. You'll see in a minute why sometimes that will be helpful. But before we jump into more examples, we need to make sure we don't make any mistakes with this. If we had the nth root of a plus b or a minus b, that is not equal to the nth root of a plus the nth root of b. That rule only applies if we are multiplying on the inside of the root. So if we had a plus b or a minus b, it would not work. And an example to show that is if we had the square root of 1 plus 1, that was not equal to the square root of 1 plus the square root of 1. Those two values are not the same. So let's go ahead and move on. Let's solve for this. If we had 25 to the power of negative 3 over 2, we can first use the negative exponent rule. If you have no idea what that is, you can check out a video on that. It'll be in a playlist in the description. But that way we don't have to work with negative exponents. So this would now be equal to 1 over 25 to the power of 3 over 2. Now using the radical rule we just learned, we can rewrite this as the second root or square root. Most people don't write that 2. Most people don't write the 2 value here, so it'd just be the square root of 25 cubed. Now this is where rewriting it with that exponent on the outside is helpful. If we wrote it like this, where we have the square root of 25 cubed, that is going to be easier to solve. Because in our first option, we would have to cube 25 and then take the square root. Versus our second option, we can square 25, which is equal to 5, and cube it. So 5 cubed would be equal to 125. Therefore, our final answer would be 1 over 125. Let's check out a more complicated example. So in this one, we have the square root of 60x squared times y squared times z to the power of negative 11. The first thing we want to do is get rid of any negative exponents. And by doing that, we're going to apply the negative exponent rule again to z to the power of negative 11. So we would move that down to the denominator. So we'd have square root of 60 x squared times y to the 6th over z to the 11th. Now what we want to do is we want to factor out 60. And so if we made a little tree like so, 60 would factor out into 6 times 10, which those values, we'd have 2 times 3 and then 2 times 5. So if we wrote that out, it would end up being 2 squared times 3 times 5. and our x's and y's would stay the same. Now, since we have this square root, when you have a square root of a squared number, right, so 2 squared, for example, the squares would cancel. So in order to simplify this, we want to write as many of these expressions as a squared value so that we can have more cancel out. So we can rewrite y to the power of 6 as y squared times y squared times y squared. And then in the denominator, z to the 11th can be z squared 5 times and then times z. Now this is helpful because if you recall our radical exponents we just went over, or our radical rules we just went over, we can now apply a radical to each and every one of these. And when we do that, all of these squares are going to be canceling out. And what we're going to be left with is 2 times the square root of 3 times 5 times x times y times y times y. And then in the denominator, we got our 5z's times the square root of z. So if we solved and simplified all this, we'd be left with 2 times the square root of 15 times x times y cubed over z to the 5th times the square root of z. Now some people prefer to not have any square roots or radicals in the denominator. They would rather have them all in the numerator. I'm going to leave this example how it is, but I'll show you how to do that in the next example. So in this one, we're going to rationalize the denominator. And what that means is to get rid of any radicals in the denominator. So in order to do this, we want to multiply both the numerator and the denominator by the square root of x. And once we do that, our denominator would be the square root of x squared, which means they can cancel. So when our square roots cancel here, we're going to be left with a 3x times square root of x over x. And so our 2 x's will cancel, which means our final answer will be 3 square root of x. So that's how you would rationalize the denominator if you were asked to do so. Again, some people don't care, others do. So as a recap, in this video we covered these 3 topics. We talked about fractional exponents, as well as how to pull things out of radical signs, and then rationalizing the denominator. So if you have any questions, please comment down below. Otherwise, if you found this video helpful, please like and subscribe. I've also included some products I use to make studying easier in the description, so please check those out, as well as the current book I am reading. Thank you for watching.